We've covered what SQL is, what a query is, and why SQL is a declarative language. But how did SQL come to be? Where did it all start? Let's dive into the fascinating journey of SQL's development. The original name of SQL is actually SQL, which stood for Structured English Query Language. However, due to a trademark conflict with an aircraft company, the name was changed to SQL, which stands for Structured Query Language. Despite the change, you'll often hear people using both names interchangeably. Some people using the SQL name, and some of them are using the SQL. And the story begins in 1970 when Dr. Edgar F. Codd, a researcher at IBM, published a groundbreaking paper titled A Relational Model of Data for Large Shared Data Banks. In this paper, he introduced the concept of a relational database model, which laid the foundation for SQL. The relational model proposed organizing data into tables with rows and columns, making it more efficient and intuitive to manage and retrieve data. After two IBM developers, Donald D. Chamberlain and Raymond F. Boyce, are inspired by Codd's relational model, so they decided to bring his vision to life. They developed the first version of SQL or SQL between 1974 and 1975. It was designed to be easy to use and closely resemble natural English, which contributed to its widespread adoption. In 1979, Oracle, then known as Relational Software Inc., released the first commercial implementation of SQL, making it available to a broader audience. The development of SQL was a major milestone in the field of computer science. It provided a standardized way to interact with databases, making it easier for people to manage and manipulate data. SQL's simplicity and effectiveness quickly made it the go-to language for database management. Its ability to handle large amounts of data efficiently made it indispensable in various industries from banking to telecommunications. One of the critical aspects that contributed to SQL's success was its standardization. SQL is standardized by organizations such as the American National Standards Institute, ANSI, and the International Organization for Standardization, ISO. The first SQL standard, known as SQL 86, was published by ANSI in 1986, followed by ISO in 1987. These standards have been periodically updated to incorporate new features and capabilities, ensuring SQL remains relevant and robust. This standardization means that SQL has a consistent set of rules and syntax, which ensures compatibility across different database systems. For example, SQL code written for an Oracle database can be easily adapted to work with a MySQL or PostgreSQL database with minimal changes. The standardization of SQL has played a crucial role in its widespread adoption and longevity. It ensures that developers can rely on a consistent language for database management, regardless of the underlying database technology. This consistency also facilitates learning and using SQL, as the core concepts and syntax remain the same across different systems. SQL's influence extends beyond just querying and manipulating data. It has inspired numerous other database technologies and query languages. For instance, new SQL databases combine the scalability of NoSQL systems with the ACID, atomicity, consistency, isolation, durability properties, and SQL query capabilities of traditional relational databases. Furthermore, SQL concepts have been adapted for use in big data technologies like Apache Hive and Google BigQuery, allowing SQL-like querying over massive datasets. To sum up, the history of SQL is a story of innovation and standardization. From Edgar Codd's groundbreaking paper to the development of the first SQL version, by Donald Chamberlain and Raymond Boyce, SQL has evolved into a robust and standardized language for managing databases. Its continued relevance and widespread use today are a testament to its foundational principles and the vision of its creators. Next, let's delve into the reasons why Code's relational model was so revolutionary and how it transformed the way we use databases. We will explore the impact of the relational model on data organization, querying, and the overall efficiency of data management systems. Stay tuned,